Hello, everyone. I hope you've had a great week at SQL Bits. We're almost done. And today I'm going to talk to you about intelligent query processing. The cool thing about intelligent query processing, if you haven't heard about it, is that there are a lot of things about T-SQL that don't run very fast. Sometimes we call some of these anti-patterns, things that are not necessarily recommended, but folks still do them. And instead of trying to change the code, Microsoft has added some optimizations to the SQL Server engine to just make these run faster. I like that a lot. At one time, I made my living by helping folks doing query tuning and trying to take care of those problems. So in some ways, I'm like, no, you must write your queries better. But on the other hand, I do want people to be happy with SQL Server and be able to get really good performance without having to make a bunch of changes. So I still like it. All right, I'm Kathi Kellenberger. Some of you might know me as Aunt Kathi on Twitter. I'm the editor of Simple Talk at Redgate. I'm also a DevOps advocate. I teach people in St. Louis and Kansas City T-SQL to help them get into tech careers. I've changed a bunch of lives, or helped, not me completely, but the program I teach for has changed hundreds of lives. It's amazing. The most important thing to know about me is that I'm a lifelong learner and teacher. If you, I joked earlier, if a baby starts asking me questions about SQL Server, I'm like, oh yes, let's talk about SQL Server. Let me get a whiteboard out and explain things. So I love learning new things and I love sharing what I know. So you may have seen this diagram before. This is from the Intelligent Query Processing page in the SQL Server documentation. And the blue rectangles are features that came out in SQL Server 2017. All of these are also available in Azure. Typically, these features will show up in Azure SQL Database first before they show up in on-premises SQL Server. That's not always the case, but that's usually what happens. The green rectangles are things that came out in SQL Server 2019. There's quite a few things that's coming out in SQL Server 2022. I can just kind of list some of those. I'll list those at the end if I have time. But if you haven't checked out the mini Microsoft sessions this week, be sure to take a look at the recordings. Things that like Bob Ward and Buck Woody, Kendall Van Dyke, they've talked about these items that I can't get my hands on yet. And then the new release is coming out. The items that I have highlighted, hopefully you can see that, the items that I have highlighted require either Azure SQL Database or Enterprise Edition. So there's a few of them that you're not going to get with Standard Edition or lower. All right, so let's talk about the first one, batch mode adaptive joins. So what this particular feature does is look at the number of rows coming through your query, okay? Sometimes it's better to do a clustered index scan and a hash match. I'm talking about looking at the execution plan, okay? So what's happening under the covers, and hopefully quite a few of you are familiar with that. There's two different ways that SQL Server might process some of these queries. If there's a low number of rows coming through, it might use this technique called nested loop. So even if you write the query one way, but under the covers, SQL Server can choose one of two different ways to solve the problem. Here's the issue. SQL Server tries to save time by caching these plans. All right, so what happens then is if your data is skewed, if you have a particular value that there's thousands and thousands of rows, but otherwise your data is pretty maybe you've got 10 or 12 of the other things, it's going to depend on what's the first query that runs, what's the parameter of that first one. It's really, we call it parameter sniffing. So starting with 2017, they introduced this feature called batch mode adaptive join. And it required a column store index. So column store is a feature that's been around for quite a while, used mostly in data warehousing. But what they did is said, okay, if there's a column store index involved with this query, we're going to save both plans and switch back and forth based on the parameter. So that solves that problem. You don't have to recompile, it'll just automatically switch. So that was in 2017 and Enterprise Edition only. I'm not sure if I have another slide, but in 2019, they eliminated that column store index. No, they didn't. I'm sorry, I'm thinking of something else. Scratch that. So yeah, it started in 2017. It does require a column store index to be involved. It's a different one that doesn't need that anymore. Okay, so let's take a look at an example. All right, I'm going to use the Wide World Importers database. And I'm going to use a stored procedure, and I like using stored procedures, and I'll use that throughout just to make sure that the query's parameterized. Because if let's say I select a query to run, and the next time I run it and I accidentally have an extra couple spaces I've selected, SQL Server will treat that as a different query, even if there's a space different. If I call it with a stored procedure, then SQL Server sees it as the same thing. Let me get rid of that. So, all right. So for all of these features, they depend on the compatibility level. If I bring a database over from an older version of SQL, or I upgrade my SQL Server and leave the database at the older compatibility level, I won't be able to get these features. All right. So in order to turn them on and off, I'm going to change the compatibility level. So you're going to see me do that throughout. So I'm going to set it to, I think that's 2016. I'm also going to free the procedure cache, and I'm going to run this with a particular value, and let's see what happens. So this one has 206 rows that comes back. What I'm really interested in here is the plan. So we've got a cluster index scan, we've got that column store I talked about, and it's a hash match. So for this particular amount of data coming through, this is the correct plan, all right? If I free the procedure cache, so that's going to get rid of any cached plans. This is not something you want to do on your production servers, but I can do it in a demo. So with a different parameter, I have only got 5 rows. It's the same code, but if we take a look at the plan, it's very different. In this case, I have a nested loop. I'm not going to go into what the difference is between a hash match and a nested loop, but the nested loop is very efficient when there's a tiny number of rows. The hash match is efficient with a large number of rows, okay? So each parameter has a plan that's good for that particular parameter. All right, so now I'm going to go ahead and run the 360 that we saw before needs a hash match, and it's stuck at nested loop. So now all of a sudden, if I like to run this stored procedure, or my software is running the stored procedure against 360, and usually I'm talking about more rows. They ran fast no matter what, because this is a small amount of data. Oh great, yesterday when I used 360, it ran fast. How come today it's running slow? You know, those are those really hard problems to solve. And in this case, it's because that plan for a particular value is saved in cache. All right? So what I'm going to do is just switch compatibility level to 150, which is 2019, I think, and run each one of these. I'm going to run them together just to make sure that it doesn't fall out of cache by itself. All right, so I've got my small amount of rows, my large amount of rows, and previously it would get stuck at the nested loop, all right, because of the small number of rows. In this case, I have this new thing called an adaptive join. This is really interesting. Well, let me just run one of them, because I got too much going on there in that execution plan. All right, so let's just take a look at this. We've got this new thing called adaptive join, all right? So adaptive join means we've saved two different versions, two different plans for this particular query, and we're going to use the one that makes sense for the number of rows that goes through. So if we take a look a little bit closer here, we'll see that we have two different spots where we're pulling the data through, two different lines. This one says 0 rows, this one says 5. So what's happened is that there's two different ways that the data could come through the plan, and in this case, it came through this bottom one. They both say clustered. This one is a clustered index seek, this one is a clustered index scan. So they're pulling the data in different ways. If I click on this adaptive join, and I'm going to hit F4, no, I'm going to go to properties, and if I look at this, I can see that there's this new thing. I don't see where it says estimated join type. Okay, down here, estimated join type. This is something we haven't seen before, this feature. So the estimated join type is nested loop, and the actual join type is nested loop. Okay, so now instead of just saying this is what it is, we have an estimate first. So let me go ahead and run the next one with the other parameter, the 360, and see what happens. Again, it looks like the other one did. However, this time the rows are running through the clustered index scan. And if I look at the properties, I'll see that the estimated join type is still nested loop, because that was the first query that ran, but the actual join type is hash match. So this takes care of a lot of, or at least some of those parameter sniffing issues, okay? So any questions about this? Yes?
Does it always assume that you should have an adaptive join, or is it based upon the statistics from when you do your first run that it says that could go either way, I'll make it adaptive and have both options?
Okay.
Does that make sense?
Right. So the question is this looking at how many rows, or looking at the skewness, I guess, of the looking in the statistics at the skewness before it decides on the adaptive joins? I am not 100% sure, but what I think is happening is if there is a column store index involved, it automatically does this, is what I've seen. You know, it's got to have that column store index. So I think that's what's going on. I hope at some point that they take away the requirement to have the column store on this one. They haven't announced that for 2022, so I suspect if they haven't announced it at this point, you know, who knows? It might be something they've got, or at least I haven't seen it announced. I've been trying to pay attention. All right, so that's the first one. Were there no remote questions? Okay. All right, so let's talk about the next item. So the next issue that can come up is an issue that happens with certain types of table-valued functions. The thing I hate is that I hear people say all the time, just change that to a table-valued function and it will run fast. Well, it depends, right? It depends. There's two types of table-valued functions. One type is more like a parameterized view. All that's inside that function is just a query, and you can pass parameters in. The other type of table valued function, you can have loops, you can have table variables, you can call other functions, you can have all kinds of stuff in there. Those typically don't perform very well, right? So in certain situations, Microsoft has improved this performance of this. But the way that they did it is that if there's no, I'm going to call it parameters that are sending in dynamic values. By dynamic values, I mean like column names. If you're sending in a column name, it could be different for every call to that function. If it's no parameters or hard-coded parameter, like with a variable or hard-coded parameter, what the optimizer is doing is going ahead, materializing that table, not calling it over and over and over. So that's what happens with these. If you have 1,000 rows coming back in your table and you're calling one of these, it's going to run 1,000 times. But in this case, it's always the same table for every row if we've got hard-coded values coming in. So SQL Server will now materialize the table. You know, you don't have indexes, you don't have statistics, but at least we can now say, hey, we know how many rows are in here, and we can at least adjust the plan to take care of that. Previously, it assumed that there was 100 rows. If you were calling a multi-statement table, it's hard to say, multi-statement table valued function, it assumed 100 rows. Well, there could be 5 rows, there could be 1 billion rows, who knows? So this way, we're materializing the table once and then figuring out how many rows, adjusting the plan, and going from there. So this is new in 2019. So let's take a look. So it doesn't take care of everything, but it takes care of some of the things. Oh, this says 2017. I wonder which one's right. Might have to, I've got strange, somewhere along the line I made a mistake on the, let me check really quick. I can find out. Interleaved execution is 2017. So my slide is wrong. All right, so I'm going to set the compatibility to 2016. This is a multi-line function. I am calling parameters, a start date and an end date. I'm returning a table of just the product ID and the total sold. And I'm like taking that end date, adding 1, I'm inserting into this table variable, and then I'm returning the table variable. So there's things going on. There's more things going on than just a query with parameters. So this is multi-statement. Very simple multi-statement. They're often very much more complicated. All right, so I'm going to call that table variable, call that table valued function with a couple of hard-coded rows here. I'm not calling it with columns. And it comes back with the, let's see, what am I getting returned? I'm getting returned the total sold, and that's really what I'm getting back here, the total sold. And I'm joining on product ID, returned from that table valued function. If I set the compatibility to 2017, well, let me go back. I'm going to turn on the execution plan here. These are going to run pretty fast because there's not much going on. There's not many rows. I think before I got a new laptop, it actually did run kind of slow. But I got a new laptop a couple months ago, and I'm like, why is this running so fast? If I look at the execution plan, I'm seeing table valued function, 100 rows, all right? So I could have more rows than that. I could have less. It just automatically says 100 rows. The other thing is that it doesn't tell me that what's going on under here. It doesn't tell me about other tables that I'm touching. It shows me that I'm touching the product table, but if we go back and look at that function, I'm touching the sales order header, I'm touching sales order detail. I don't see that in the execution plan. So this is just really like a black box to me. And it's just assuming it's 100 rows. All right? So if we set the compatibility to 2017 or later and call the same function, then now it's giving us the exact, actually we're still not seeing the other tables that are getting called. But the cool thing is that we now have the correct value. It's only 51 rows. So that's good. I mean, 51 and 100 is not that much different, but let's say we had 30,000, a million rows, whatever. So I think really the benefit of this is that we're not calling that function over and over and over, which I think is probably what's happening originally, and we're getting back the correct cardinality. So if the plan needs to adjust, it can. Okay? Any questions about this one? Yes? There's no way I can hear you. Can you come up?
What edition is it available in?
This one's 2017.
Standard or enterprise?
Oh, standard. Yeah. So the question was, which edition of SQL Server is this one available? And the question is, it is available in standard edition. It might be available in earlier ones too, but I don't really pay attention to like Express or anything like that. Okay, so no questions, I guess, online. All right, so let's keep going. Where am I here? All right.
Just with that one, is that recomputed every time? So if the function comes back with different, if it comes back with a different cardinality on different ones, does it cache that?
Oh, yeah. Oh, that's a really good point. I believe that it does cache. So the question is, does it cache that number? And actually, I'm thinking that it might cache that number. So I could be wrong. There's two features that are very similar. The next one I'm going to talk about, which is the table variable. I know that one gets cached. I am not sure on that function. I'm thinking I might have to have you contact me and I'll find out. Because I know on the table variable one, it does cache it. But on this function call, I'm not really sure. Not sure on that one. Good point. So I will, I forgot to bring cards. It's like I haven't given anyone a business card in like over 2 years. But if you didn't grab my email address at the top, then I can show that again before we're done. You can contact me. I will find out. All right, so the next one is very similar. Table variable, not table valued, table variable deferred compilation. So this is the same kind of idea. A lot of folks will use table variables like in stored procedures instead of temp tables, which if you're working with 10 or 20 rows, that's great, but you're working with thousands, not such a great idea. So these will have, before this feature, they will have an estimated cardinality of 1 row, even worse than the multi-line table valued function. And again, it's going to go ahead and look at the number of rows in that table and adjust the plan. This one is definitely cached, the plan is cached with that number of rows, definitely. And this one was introduced in 2019 and available in standard as well as enterprise. So let's take a look at this one. This one is table variable. All right, so I've got a procedure here that creates a table variable, throws some rows into it, and then uses that in a join. So that's what my stored procedure does. And by the way, I did a whole thing on Microsoft Data Expose with Anna Hoffman probably about a year ago, just on this feature. So I talked pretty extensively about this one feature. So you can go out and grab that. I don't think I have the link to it quickly, but all right. So we're going to set the compatibility to 140, which is 2017, and make sure that this is on, and call the stored procedure. And the first part is just creating the table. We don't care about that. But down here, man, it's hard to see. Down here, you can see that it estimated one row, even though there's 121,000 rows, has an estimate of one row. That's bad, right? You can see that we have a spill to disk on the sort because SQL Server didn't realize how many rows were coming through. So we've got a spill to disk. This is really bad, really, really bad. All right, so if we switch to SQL Server 2019, then to do the same thing here. Okay, oh, now we've got a much simpler plan. We have a hash match. I suppose the other one was probably a nested loop. We've got a hash match now. We have the correct value coming through. Again, this value is going to be cached. So if your table variable is always getting populated with approximately the same number of rows, this is fantastic. This is really good. If it's going to be, sometimes it's 10, sometimes it's 1,000,000, well then it's not that helpful. So, but I think this is really good because I've been on engagements where they had used temp tables in stored procedures, and they put somebody on a project to change every single stored procedure to do table variables, and then the performance just tanked everywhere. So the lesson for that is don't use one thing, don't marry or fall in love with one technique in T-SQL. Don't do that. Always, you have everything in your toolbox. Always test and see what's best for each situation. Just like if you were doing a repair on your house, don't assume that one technique is always going to be the thing to use. Table variables. In fact, I just wrote an editorial on SQL Server Central a couple weeks ago, and talked about this. How people, when table variables came out, people just jumped on the bandwagon, and this has been years and years ago, and thought that they were the solution to everything, but they're not. There's never a solution to everything. All right, any questions about this one? Nope. Okay. All right, let's move on then. All right, Scalar UDF inlining. This particular feature, I guess, would have been really helpful for me back when I was doing consulting, because I would go to shops that just, like a lot of shops that didn't have a database or a SQL Server expert on staff, because they would just use Scalar UDFs. Scalar meaning it returns one value, it doesn't return a table. They would use these like crazy and nest them. And I had one particular client who had a query that took an hour to run. And we did add a couple of indexes, but we unwound about 5 or 6 UDFs and got the query to run in under a minute. You know, just in a couple hours in an afternoon, I was able to help them that much. The problem was all these UDFs make sense in procedural object-oriented code, does not make sense in SQL Server. However, they're heavily used because it makes your code pretty. So if this doesn't work, so what happens is, let's say that my user-defined function has a formula, and I put it, and I'm like, well, you know, I would always like to just use this function instead of typing that whole formula out in the select list, all right? So it makes sense, but what happens if you have this feature turned on, which is introduced in 2019, is that SQL Server will take that formula or whatever it is and stick it in the select list and under the covers. You don't see that, but all of a sudden something that runs slow will now run fast. It does not work for all UDFs. There are, if you're going to, consider this, go out and look at the documentation because there's a list of like 20 different reasons why it won't work. But occasionally it will. So let's take a look at that. I'm trying to think of when my session's done, and I forgot. I forgot to look. Is it 3:30? 3:40. Okay, good. I completely forgot to pay attention to that. All right, Scalar UDF inlining. And I think I lied to you earlier. This is the one that I did with Microsoft's, with Anna Hoffman. It wasn't whatever I said earlier. I don't mean to lie, it was a mistake. All right, so I have a function here that I send in a product ID in a year, and I get back the number of units that were sold during that year. All right, I'm going to set the compatibility level back to 2017. I'm going to drop clean buffers just to make sure I'm not cheating, and call that function and make sure that that's turned on. So if we look at the function, you can see we're calling sales order header, sales order detail, and I'm calling it with the product table. And it ran fast. This is not a big table. If I look at the execution plan, I can see there's this compute scalar of 0%. All right? It doesn't think that there was really any effort. And I don't see that I've touched those other tables. All right? And this one ran pretty fast, but if there were a lot of rows here, it would just not scale at all. It would be much better to create, just to join on those tables. That's the thing. There are so many UDFs out there that would just make more sense. Just have it in the join. Your code's not as pretty, but it'll run better. What's more important? All right, so I'm going to switch to 2019. And I'm going to call it again. And again, it ran fast. This time, it looks much more complicated. But what SQL Server did under the covers in this case is go ahead and join on those tables instead of calling that over and over. So I did, like that one customer that I was telling you about with like all those nested scalar UDFs, they didn't realize that those functions were getting called over and over and over. And so back then, I try to always be using extended events now, but back then I fired up Profiler and we ran this thing and showed them how this function, there was in fact one of them that was just a hard-coded value going into it that was getting called over and over and over and over and over. And they're like, oh, now we see what's going on. So under the covers, instead of calling that function over and over and over with that product ID, what we're doing is changing it to a join, which you could have done. If it was a formula, it would just stick that formula in the select list. So I really, really like this. So there's a few things that it will not do. It will, if you have an if in your function, it's fine with that. So this one's got an if. So conditional logic is fine. If we take a look at the execution plan, we can see that it worked. If I have a loop, it's still going to have the old behavior. Your function will work, but you're going to have the old behavior. You won't have the new inlining. So with the loop, I got that old compute scalar black box. And there is a function you can call to find out if your function is inlineable, so you can know whether or not it is, taking advantage of this feature. So, is inlineable, and the loop is not. Okay, so you can see what's going on in case you're wondering. But there's a long list of requirements. Even having a get date or a any date function, or like get date, get the system date, will cause it not to be inlineable. There's a lot of different reasons. Okay, let me double check that my session really does end at 2, because I thought they were only 50-minute sessions. Pardon me? Okay, 3:30. That's what I was thinking. Okay. So I got to get going. All right, batch mode on rowstore. So rowstore has to do with column store indexes. This is a technique in column store indexes where it's a big problem, like a big aggregate, like in a data warehouse report, and SQL Server will break the problem down into pieces. This is not parallelism. This is kind of like, let's just take these rows and separate them out. It's not parallelism. So previously, it had to be a column store index to take advantage of this technique. Starting in 2019, Enterprise Edition, this, for large aggregate queries, this will kick in. All right? If it's just a small query, it's not going to kick in. It pretty much needs aggregation. So again, Enterprise Edition. And let's see, batch mode on rowstore. I'm using a bigger table to show this. This is a script you can get if you like to play with a little bit more data in AdventureWorks from a guy named Adam Mechanic. He also wrote Who is Active. If you use that at all, he's the author of that. Really smart guy. Okay, I'm setting the compatibility level back. And I'm going to show you that this is a big table. It's got 31 million rows. It's a pretty nice table there. We're going to set the compatibility to 2019. And wait a minute, I should go back. Let's take a look at the execution plan. Things are running too fast on this Nukes machine. This should have, I think in my older laptop, this took like 10 seconds, and now it's just instantaneous. But we can take a look at, do we have a statistics I/O turned on? I don't. Everything's running too fast today. But this is what the plan looks like. It actually is using parallelism because there's a lot of rows. And I'm going to switch it to SQL Server 2019 and drop clean buffers. It's really sad when 31 million rows runs too fast on a laptop. And I don't even have a lot of RAM assigned to my SQL Server. Okay, so what I really want to show you, so the plan doesn't look that much difference here, but what I want to show you, I want to look at the properties, and there's some new things that you'll see over in the properties. Batch mode on rowstore equal true. All right, so it's telling you that this feature kicked in. All right. I apologize that I didn't realize that the query before was going to run so fast, because the last time I gave this session, it took a while. It took a few seconds. Now it doesn't anymore. But that's the difference. So we'll have, you can see in the properties that batch mode on rowstore kicked in. So here's where I really love it. If you know me at all, you know that windowing functions are my passion when it comes to SQL Server. There's a few, like this count over or sum over, that don't run very well, don't scale. They run, but they don't scale very well. So this feature actually kicks in for those. So let's see, this one I'm going to have to go back to the old compatibility level. Hey, this one's taken a while to run. Yay, at least I can show you something as an improvement. So it took a while to run. It took 6 seconds to use a count over, all right? So if you're not familiar with count over, there's probably a dozen videos out there of me talking about it at different events. I'm going to go ahead and drop the clean buffers just to make sure you know I'm not cheating. Switch the compatibility level to 2019 and run the query again, and this time it should run quicker. 2 seconds. So there you do see an improvement. So with that particular type of window function before 2019, they just didn't scale. And there was not much we could do about it. Now with this new batch mode on rowstore, all of a sudden they run faster. All right? So that is, I'm really happy about that. So questions about this one or anything I've talked about so far? You got one?
Yeah, I was just wondering whether there's any detail on sort of how it decides when to do that, because obviously your batch code for effectively you've got a big
Right.
with a small number of options.
Right. So the question is, when does this feature kick in? Microsoft has not published when it kicks in. When I have played with it, I noticed about 130,000 rows. But I would assume that it might depend on the particular query. But me just playing with it, you know, when it first came out, I was seeing it around 130,000 rows. It won't kick in unless it is a large amount. Is it dependent on any indexing? Not that I know of. Yeah. So, all right. Let's see what else I've got. I've only got 2 more. Let's see if I can get through them. Memory grant feedback. So this is one that is Enterprise Edition only. This is the one that was introduced for batch mode, meaning it needed a column store index to work in 2017, but they removed that requirement in 2019. Enterprise Edition only, though. So memory grant, when there's a query, SQL Server tries to figure out how much memory it's going to need. You notice that one that we did earlier where there was a spill to disk, where it thought there was only 100 rows and there was like 120,000 rows, and it spilled to disk because it didn't grant enough memory for that query because it didn't know. So what happens here is that occasionally SQL Server will grant too much memory. That's not a problem for that query, but it's taking resources away from the system, right? Or if there's not enough, often you'll get a spill to disk when which is going to slow things down. So what they did is that they looked at that and started paying attention. Oh, this particular query, we need to adjust the memory. So if you have to run it a few times, and then it'll adjust. And then the problem is, if the data is skewed and you have enough different values, it'll eventually just turn this off, all right? But, so I kind of like it. If the data is not too skewed, this is fantastic. But if it is, then it's not great. However, in 2022, they've fixed this problem. I don't think I've seen a demo of it, but I heard them talking about it yesterday in one of the sessions. So they've, Buck Woody and Kendall Van Dyke session. So it's better. 2022, it's going to be better. I'm not going to show this one. I'm going to, for time's sake, I'm going to skip that one. It's not as much fun. So this is another one that has, this one is kind of different. Everything I've shown you so far, you really didn't need any changes to your code to take advantage of. This one is a new function, and let's say that that you're monitoring like data coming in from machinery on a factory floor, or you're measuring something, let's say log files from something, and you need to get a count very quickly, but you don't care if it's accurate because it's changing, very fast. So instead of using count distinct, you can use this function called approximate count distinct. And it will not give you the exact answer, but it will give you an approximate answer very quick. And also in 2022, they are introducing a few other ones, like for the percentile types. So there's a couple of other ones they're introducing in 2022 that are similar. So these particular ones do require code changes. All right, I don't have a lot of time left. I just want to mention that there are some options if you decide, so you saw me turning these features on and off, right? I turn them on, I turn all of them on, or I turn them all off. There are database properties. There's a database property for each one. You can turn it on or off, and if you, they didn't ask us to upload the slides, but if you look, I've got a resource, my GitHub, I've got all this code you could download. So for every property, every one of these, there's a database property. So if you say, I don't like this particular one, you can turn that particular one off. Also, they have a query hint for each one. So if you have a problem with one particular query and these features, you can turn it off for one query. All right, so 2022, my favorite, I can't wait to get my hands on it and demo it, parameter-sensitive plan optimization. This is similar to that first one I showed you. This is that problem where sometimes you have a clustered index scan and sometimes you have a lookup, a seek and a lookup. Do you guys know what I'm talking about with parameters? This takes care of that. So that's coming up. Adjusting max stop. So for you DBAs out there, max stop, like how do you set it? This is an adjustment. I'm not sure if I've seen it demoed. I can't remember. I would guess it's per query. Some of these features, like if time passes and a plan comes out of cache, you kind of lose it, or if you restart SQL, you got to lose it and start over. So query store integration will keep these, like let's say it's the memory grant. It'll keep that instead of losing it. The approximate percentile, like I mentioned, and a few more. So 2022, make sure you go back and look at all the recordings from any of the Microsoft speakers, after you get home, whenever they're available. And here's some resources. You can grab all of the code that I showed today from this GitHub. If you want to take a picture of it really quick, I have uploaded the slides. You can get the link from that. Greg Larson has written an article on each of the intelligent query processing features. And Bob Ward, who's also here this week, has a nice video out there when SQL Server 2022 was first released that he talked about. So check out those, and yay, I'm done. This is the time. This is the code. If you can go ahead and fill out the evaluation. And thank you so much for spending 50 minutes with me and letting me talk about something that I dearly love.